Natural natural sciences grade 8 students. We want to look at we just want to quickly go and quickly talk about visible light as part of our syllabus requirement. So what is visible light and some properties and characteristics of visible light is what we just gonna talk about. So visible light is part of the electromagnetic spectrum that humans can see, consisting of different colors that combine to form white light. We are saying electromagnetic spectrum that humans can see, consisting of different colors, that can combine to form white light. So now, the visible light is a term that is used to describe all the forms of radiation, all the forms we are saying describe all the forms of radiation that we are able to see by our own eyes. So radiation, we are talking about the movement. This is the movement of light. So light moves by radiation. So now that's for us to be able to see things, light from the objects must enter the eyes first. I guess as you can go, you should be able to understand that light is the stimulus of what? Of vision. Ability to see is because of the light. If light is not there, we are saying we are able to see as a result of light. Light is a stimulus of what? Of vision. So visible light is the range of the electromagnetic spectrum that humans can detect with their own eyes. If they are able to detect, we are saying are able to see with their own eyes, typically between 380 and 700 nanometers. This is just the measurement. So now, these colors, including red, we have got such colors red, we have got orange, we have got yellow, we have got green, we have got blue, we have got indigo, and violet. They have varying wavelengths and frequencies. They are dynamics in terms of the movement of their waves, as to say, how are they moving? Others have got short waves, others have got large, from measuring from each troop to the troop. We can see that as they are just different measurements that we can talk about. So when white light is separated, such as in a rainbow, these colors become visible due to dispersion. When white light is separated, for example, I guess we know a rainbow. It is when it is separated, the colors becomes visible due to dispersion, which is the bending and separation of light. The dispersion is the bending and also separation of light. So when the white light is separated, the various colors can be seen because of the bending and separation of light. So white light like that form, we are saying white light like that from the sun is a combination of all the colors of visible spectrum. It's actually a combination of all the colors of the visible spectrum. So properties and behavior of light, the visible light, a component of the electromagnetic spectrum, exhibits both wave like and particle like properties. They both provides wave like and particle like properties, the visible light. So a wave, as you can see, it's a movement with a up and down swing that we can check. So it can be characterized by properties like wavelength, the frequency, the intensity, and polarization. So visible light interacts with matter through reflection. I'm sure we are going to talk about these. We are going to talk about the reflection of light, the absorption of light, and also transmission, which determines how we perceive colors and the appearance of objects. This is about what? About sight. This is about sight. This is about vision. in other terms. So what we need to understand is that wavelength and frequency, visible light is characterized by its wavelength distance between wave crest. Wavelength is actually, we are saying wavelength is the distance between wave crest. As we can see the distance from peak to peak is what we call the wavelength. That is the wavelength. And then different wavelengths are perceived as different colors. I'm going to show you that we are coming to that. I'm going to show you just now. So the size of a wave is measured in wavelength, and then wavelength is the distance between two corresponding points on the consecutive, on two consecutive. Normally, it is done by measuring from peak to peak or from trough to trough. Have a look at the following diagram that we can use to illustrate that. So we are saying the wavelength is given as this one, from peak to peak. So that distance is measuring the wavelength. So the wavelengths of different colors of visible light are different lengths as shown in following diagrams. We are saying different lines or different colors of different colors of visible light are having different wavelength. The different wavelength, like we see, this is red. We can see that the wavelength is just something different. This is red. We can see a different wavelength, and then we can also see this one is blue. And then I'm saying, if you can see from peak to peak here, it is short. This one is short wavelength, and then it has got a long wavelength. It is long. So we are saying the colors have got different wavelength, as can be seen there. So we can also talk about the frequency of wave. If your wave has a long wavelength, then it has a low frequency. It has a short wavelength, then it has got high frequency. That is also one thing that you need to take note of. So visible light, we can talk about the colors like light orange, red, wavelength. We are saying red light, you have the longest wavelength. Such colors such as light, we are saying orange, red, you have got the longest wavelength and lowest frequency, and violet, indigo, blue, and you have short wavelength. They have short wavelength and highest frequency. As to say the length of the whole wave is the frequency. So intensity refers to the brightness or power of light. When we talk about intensity, it is the brightness or power of light. It decreases with the distance from the source. I'm sure that is true, following the inverse square law. So as we move away from the source of light, the intensity also decreases, which is the brightness. I'm sure that is true. We cannot be able to have the same brightness of light when we are closer to the source than from the far distance. So polarization, light waves can be polarized, meaning their oscillations are aligned in a specific direction. And then wave particle duality, we are saying wave behaves as both a wave exhibiting interference and diffraction and a particle. That has been identified that we can also see a wave and particles in terms of light, in terms of uh, visibility of light. So the speed also, when we are still in light, in a vacuum, light travels at a constant speed and approximately 299,797,456 meters per second. That is like the speed of light. So we are going to find somewhere where we are going to talk about, or where we can be asked to calculate the speed of light when given some context and stuff. And then the behavior of light, of visible light, reflection, light bounces off surfaces, the behavior of visible light. light bounces off surfaces. Smooth surfaces reflect most of the light, while rough surfaces scatter it. That is one behavior. Absorption. Some materials absorb light, converting it into other forms of energy like heat. These we are talking about the behaviors. And then transmission. Light passes through transparent materials, which we can say, for example, we can talk about a window pane. A window pane. When you are inside a house where the curtain is not there, it is possible to see what is happening outside. The transmission, visible light, we are saying it is able to see because of the material that is transparent. Reflection, light bends when passing from one medium to another, e.g. from air to water. I'm saying light bends. If you are going to continue with your sciences, you shall see the reflection of light that is caused by the pupil as the light enters the ear, the eye. We're talking about the vision and eyesight. So diffraction, light waves bend around obstacles. Diffraction, light waves, they bend around obstacles and spread out when passing through narrow openings. And then we can also talk about the interference. Light waves can interact with each other, creating patterns of constructive and destructive interference. When light waves can interact with each other, therefore they can create patterns of constructive and destructive patterns. And then scattering, light can be scattered by particles in the air, causing phenomena like blue sky. So when you look in the sky, we say it is blue because it is light that has been scattered by particles in the air. That is the furthest distance our eyes can see. So therefore it causes the scattering of the light. And then let's talk about ray diagrams. It is a diagram, a ray diagram is a drawing that shows the path of light. And then light rays are drawn using straight lines. Light rays are drawn using straight lines and arrowheads because light travels in straight lines. That is when we are talking about ray diagrams, a diagram that actually drawn to show the pathway of light, and then they are normally drawn with the straight lines because light travels in straight lines. And then light travels in straight lines, which is why sometimes we are not able to see light around corners. When there is a corner, we say it is usually in a shadow because the light cannot bend. Because when light travels from an object, that is around a corner, the light is unable to bend around the corner and reach each eye. So that is why we are saying the light travels in straight line and it cannot bend. It cannot get into corners. And then light radiation refers to how light energy travels through source and spread out in all directions. This energy is transferred through electromagnetic waves, and the visible light is just a small part of radiation spectrum that humans can detect. So we are just talking about visible light, and that is it. I guess we are going to talk about radiation light in detail. We talk about reflection light. We talk about all the other various light forms, and then we can be able to conclusively say that we have covered that. Thank you very much for your time and have a wonderful stay. Keep on subscribing and sharing our channel so that we can grow, so that we can go together, and all the best in every exam that you are to write. You have a wonderful stay with Metric Hub.